Guys, I decided to make a video for you on balancing redox reactions, so I'm going to title it Balancing Redox. Sad face, right? These are not our favorite to do. They're a little tedious, but once you get the hang of it, if you like puzzles, they're kind of like puzzles. We're going to do some from Miss Smalling. We're just going to use these as examples. So I'm just going to write down what the problems say. So our first problem says P plus Cl2 yields PCl5. In this reaction, we know that phosphorus has a 0 oxidation number. Chlorine is in its elemental state, so it has a 0 oxidation number. This chlorine is a -1, but I have 5 of them, making phosphorus have a +5 oxidation number. As phosphorus goes from 0 to positive, that's what's being oxidized, and chlorine is going from a 0 to a -1, it's what's being reduced. This is not a traditional redox reaction, but we can still balance it. It's just a lot easier. So I've got 1 phosphorus on each side, but I have 5 chlorines and 2 chlorines, so I need to put a 2 out front. That gives me 10. I need to put a 5 to give me 10, but that changes my phosphoruses to a 2. In this one, there is no water, hydrogens, or electrons needed, and I'm done. Happy face. Our next one says 10 plus 2 plus copper plus 2 change into 10 plus 4 and copper plus 1. So in this example, we're going to have 2 half reactions, one oxidation, one reduction. So we know that 10 is going from a +2 to a +4, so it's being oxidized. It's getting more positive. And a +2 down to a +1, that makes copper the one being reduced. In this scenario, we're going to have 2 half reactions. So our oxidation half reaction is going to be 10 plus 2 going to 10 plus 4. I do not have to balance the number. There's 1 on each side, nor do I have to balance oxygens or hydrogens, but I do need to balance the charges. So because this is a +2 and this is a +4, I do need to add 2 electrons to reduce this +4 by 2 to make it a +2, so that the sides are even. I'm going to split this in half by just drawing a line. We've got copper plus 2 going to copper with a +1. Because it's being reduced, right, I need to add 1 electron to this side, because copper plus 2 plus 1 negative gives me a +1 charge. That balances out those charges. The problem is that I have 2 electrons on this side and only 1 electron on this side. So I'm going to need to multiply this whole side by 2. So I'm going to get copper 2 with a 2 in front plus 2 electrons gives me 2 copper 1s. By doing this, I can now cancel out my 2 electrons on my reactant and product side. So my reaction is going to be 10 plus 2 plus 2 copper 2s give me 10 plus 4 plus 2 copper 1s. That is my balanced redox reaction. Okay, let's do a third example. In this third example, we're going to have copper solid plus hydrogen ion plus nitrate ion, producing copper 2 plus NO2 gas plus H2O. So in this third example, we're going to split these into our 2 half reactions. Our first half is going to be the copper with a 0 state being oxidized to a copper +2. So Cu goes to Cu +2, and I need to add 2 electrons to balance that charge. On the opposite side, right, so on my reduction side, I'm going to have H plus NO3 minus are going to make NO2 plus H2O. In this one, I've got 1 nitrogen and 1 nitrogen. Those are balanced. I balance my oxygens with water, but that's already done for me. I've got 3 oxygens here, and I have 1, 2, 3 oxygens here. So my waters are fine. But I need to balance my hydrogens. So I've got 2 hydrogens here, so I need to put a 2 here to balance my hydrogen atoms. Then I need to balance my charges. I have no charge on my product side. And I have a +2 and a -1, so I have an overall positive charge. So I need to add 1 electron to this side. When I only add 1 electron, I know that I need to balance my electrons because I have 2 on this side and only 1 on this side. So this whole side needs to be multiplied by 2. That's going to give me 4 H pluses plus 2 electrons plus 2 NO3s yield 2 NO2s plus 2 H2O. Now I can cancel out my 2 electrons and combine my reaction together. So now I'm going to get copper plus 4 H's, hydrogen ions, plus 2 NO3 nitrate ions. That's going to yield copper +2 plus 2 NO2s plus 2 H2Os. So here's my balanced redox reaction. Let's do one more, and then hopefully your homework will become easier. So this is our last one that we're going to do. This one is going to be, I'm going to put lines between these for, sanity purposes. Okay, so in this example, we're going to have bromine plus SO2 plus H2O. That is going to yield H plus, Br minus, and sulfate ion. I'm going to have 2 half reactions. Okay. My first half reaction is going to be the oxidation with the SO2 water and then my hydrogen ion and my sulfate ion. So SO2 plus H2O are going to yield H plus SO4 minus 2. My sulfurs are balanced. I've got 3 oxygens here, but I have 4 on this side, so I need to add 1 more and put a 2 out front here. That gives me 2 plus 2 is 4, so I've got to match that 4. And then that gives me 4 hydrogens on this side, so I need to put 4 hydrogens on that side. Then I balance my charges. I have no charges on my reactant side, but I have 4 pluses and 2 minuses, so that gives me a positive 2. I need to add 2 electrons to this side. I'm running out of space, so I'm going to put my reduction reaction below this one. So for my redox, I've got bromine going to bromide. I got to put a 2 out front because I have 2 bromines here and only 1 on that side, so that balances my bromines. And then To balance my charges, I need to add, right, 2 negatives here, so 2 electrons here. That makes me excited because I don't have to do anything else. My electrons will then cancel, and I'll add all this together. SO2 plus 2H2O plus Br2. That's going to yield 2 Br minus plus 4H plus SO4 minus 2. And you can't see that, so let me lift that up. Okay, so there's our balanced redox reaction. I hope you enjoyed watching.